Okay. Hi guys. This is going to be the pre-lab for Lab 11, part two of our neural networks lab sequence. So last time we looked at kind of how the data that we use can affect the network performance. Now we're going to look at actually kind of adjusting some of the aspects of the network. So we're going to look at changing the number of hidden layers, the number of hidden units in each hidden layer, and then we're going to look at a couple of different types of algorithms. They're different than the ones that we have been using and that we used for the first set of these labs. So because as we add hidden layers and hidden units, the training time can get a lot longer. We actually already fit the network with an additional hidden layer for you guys. So the details will kind of be included in here, and you'll reference that for the questions asking about additional hidden layers. So a deep neural net. But then when we look at changing the number of hidden units, that's where we're going to actually run the network ourselves. So we can see when we define the original kind of neural net, we have 25 hidden units. Uh, but with the network 4 that we train, we only have 10 hidden units, which you can see in the network architecture, as well as kind of like when we define the new net. After that, we're going to kind of directly compare how our networks perform on the no lazy data. I'm going to skip over that for now because it'll take a while to kind of run. But as you can see in this plot comparing the accuracy of the two nets, our network with 25 hidden units performs a lot better than the network with only 10 hidden units because that gives us more flexibility and more hidden units, more neurons to kind of um, look for a relationship between the input data and the latent class. So when we try a different type of algorithm too, so now we're going to use the gradient descent optimizer instead of the kind of default optimizer in MATLAB. We can see our errors kind of take on a different shape. So instead of kind of like exponentially decaying, we see kind of an exponential decay and then like kind of a smoothing out, like a leveling out. And we see that our training validation and testing sets all kind of follow that same smooth pattern as opposed to just our training set kind of getting better and the other ones kind of plateauing. So I can show kind of like the flexibility of gradient descent for a classification problem and how that kind of like might result in better testing accuracy. And then after that, we are going to try an additional optimizer other than default gradient descent. So here are the options: Bayesian regularization, resilient backpropagation, scaled conjugate gradient, and one-step secant. So you would take one of these and whatever the name of the one you choose is, you are going to um, put it inside of these quotes here. Um, so I will choose resilient backpropagation because I think the Bayesian regularization is pretty slow to run. And then let me pause while that runs. So you can see with the resilient backpropagation, unlike kind of like the other methods we're using, we actually did hit our maximum number of epochs instead of kind of like petering out because of some kind of performance like preset, like kind of like minimum. And then we can look again at kind of performances and look at like, there's a really quick drop off in errors. Like the model improves like super quickly, super early. And then kind of again, like over time starts to peter out. And we see again, kind of like a gap between the training and the other two sets, but a lot less than kind of the default algorithm we're using. So you'll pick one of those four and again, run the network and kind of describe the differences there. And yeah, again, if you guys still feel uncertain about neural nets, kind of like how they work, I highly recommend the Three Blue, One Brown series on YouTube on neural nets.